The topic of today's video lecture is Fullerene synthesis. So, there are different methods for the synthesis of fullerene, like graphite vaporization method, the Crushmer-Hoffman method, the graphite arcing method, the polyaromatic hydrocarbons method. So, in this video, I am going to explain the graphite vaporization method, and in the upcoming videos, I will also explain the further KH method, the Crushman-Huffman method, the graphite arcing, and the pH method. Okay, so the focus of today's video is only on the graphite vaporization method. So, moving on towards graphite vaporization method for fullerene synthesis. Well, it is a method for the synthesis of fullerene, and more specifically for the synthesis of Buckminster fullerene, that is a C60 molecule. So now, moving on towards this technique. So this is actually the setup for the graphite vaporization, and this is also known as the Smalley's technique, because Smalley is the name of the scientist who discovered this technique. So first of all, what do we have here is the vaporization laser beam strikes a rotating graphite disc, producing a plasma of vaporized carbon atoms. So what happens? We have this vaporization laser, and this vaporization laser will strike this rotating graphite disc. Okay, so this is a rotating graphite disc, and this vaporization laser will strike this disc here. Okay, so what's the next step? The pulse nozzle passes high density helium over the vaporization zone. So here we have the pulse nozzle, and this will pass the high density helium vapors over this zone, okay, over this vaporization zone, and then after passing it will go into the integration cup. Okay, so now the helium carrier gas provides the thermalizing condition necessary to cool and cluster the carbon atoms in the plasma. So, what is the requirement of helium gas? So, why helium gas is required? Because helium is actually a carrier gas. Okay, it will carry the vapors of the carbon that are going to form when the vaporization laser strikes this graphite rod. Okay, so when the vaporization laser strikes this graphite rod, there will be some carbon vapors, and this helium gas will act as a carrier gas to carry these vapors of the carbon that were formed from the graphite rotating disk. Okay, so furthermore, it also provides the condition that is necessary to cool and cluster the carbon atoms in the plasma. That is necessary to cluster means that is necessary to finally form the Buckminster fullerene after clustering. So the carrier gas also provides the wind that carries the cluster product through the remainder of the nozzle and the optional integration cup. Okay, so this is just providing a wind and it is carrying it through the integration cup. So furthermore, free expansion of this cluster-laden gas at the end of the nozzle forms a supersonic molecular beam, which is photoionized using an excimer laser and detected by time-of-flight mass spectrometry. Okay, after passing through this integration cup, it will form a supersonic molecular beam, and this supersonic molecular beam will be photoionized by an excimer laser, and then it will be detected by time-of-flight mass spectrometry, where we can detect our products. So that's how the graphite vaporization technique is done for the synthesis of the fullerenes. So, experimental results. Croto and Smalley discovered that a variety of carbon clusters were produced. Okay, so using this method, Croto and Smalley were the two scientists that discovered that there were distribution of cluster sizes. Okay, there were like C60, there were also C70. Okay, there were different numbers. Okay, so when firing the vaporization laser, when the firing of vaporization laser was delayed until most of the helium pulse has passed, a roughly Gaussian distribution even numbered cluster with 38 to 120 carbon atom resulted. Okay, so what happened? Okay, so when the vaporization laser was delayed until all of the helium gas was passed through this chamber, what happened? So the delaying caused the formation of even numbered from C38 to C120 of the fullerenes. Okay, so fullerenes with even number from C38 to C120 were formed when helium gas was passed before the vaporization laser struck the graphite, struck the rotating graphite disk. So um, moreover, the C60 peak was largest but not dominant. Okay, in this result, the C60 peak was largest but not so much dominant. When the vaporization laser was fired at the time of maximum helium density, the C60 peak grew into 5 times stronger than its neighbor. Okay, so now when the vaporization laser was when the vaporization laser struck on the graphite rod at the time when the maximum helium density was present, what happened in the results? We had the maximum concentration of C60, and that C60 was 5 times stronger than its neighbor C70. So when these conditions were duplicated but the integration cup was added. Okay, so these were the cases when there was no integration cup. Now when the integration cup was added, what happened? And the addition of the integration cup resulted in the increase in the time between the vaporization and expansion, because as you know that when the helium gas will go out of this integration cup, there will be expansion and then the formation of supersonic molecular beam. So this integration cup added time before between the vaporization and the expansion. So what is the result of this time? Well, uh, when the integration cup was added, the cluster distribution was completely dominated by C60. Okay, so as you can see here, that here we had the low density of the helium. Okay, when we had low density of the helium, as you know that there are a lot of other signals also, and but C60 is still dominant, and along with C60, C70 is also dominant here, but is not prominent. And this is the case of the low helium density. Okay, when the helium density was maximum, and in that case we have C60 that is 5 times stronger than the C70. And the last one is that in the case when the integration cup was introduced, the C60 becomes completely dominant and the other all of the other signals are just vanished. So that was the experimental results of the vaporization technique, Smalley's technique. So if you have any question, you can ask me in the comments. So that was all for today's video. Thank you and Allah Hafiz.